everybody. We're going to start with a quick review of rational versus irrational numbers, and you'll have an assignment this week on doing a little bit of algebra with them. So first, just to review the definitions, a rational number is a number that you can write as a fraction. And when you see fraction here, that means a fraction made with whole numbers. So 3/4, that's a easy example. -5 could be written as -5/1. And these are trick questions that teachers like to give you. Well, the square root of 49 can be simplified to just the whole number 7, so it's a rational number as well. When you move into the territory of decimals, if a decimal terminates, if it stops, like this first example, 0.123, we stop after the 3, you could convert this decimal to a fraction, so it's a rational number. Maybe you know how to do that. You have the tenths, the hundredths, and the thousandths place, so this is 123/1000. Also, if a decimal eventually repeats itself, you have the same thing over and over and over again, even if that goes on forever, that number could be turned into a fraction. So we start off with 5/6, but then you repeat 787878 over and over and over again. You could convert this number to a fraction as well. Now, if you can't write a number as a fraction, and once again this means a fraction with whole numbers, then it's an irrational number. The go-to example is the number pi, which is about 3.14159, but that decimal would go on forever, and it doesn't get into a repeating pattern like this example over here. So pi is an irrational number. Pi over 2 is an irrational number. Now, even though this is a fraction, when we say fraction here, we mean a fraction built out of whole numbers. The square root of 5 does not simplify like the square root of 49, so the square root of 5 is irrational. And then something like 2 times the square root of 3, we've dealt with lots of square roots like that this year. This is also irrational because the square root of 3 doesn't simplify. Now, before we move on, I have to show you one of my favorite examples of an irrational number. This number, 0.12112111121112 and so on. This is an irrational number as well. This example confuses people because there's a pattern, so you think it's rational like this number over here, but realize it's not just a pattern that you see for rational numbers. You have to have the exact same thing repeated over and over and over again, and that's not what you see over here. Even though there's an obvious pattern, we have one more 1 in each group every single time. It's not exactly the same thing, so this is an irrational number. I like that example. Now, for what you have to do this week, here's just an example. Let's say that A and B are irrational numbers. You might ask the question, well, what about A plus B? What about A times B? Can you say anything about whether or not those numbers are rational or irrational? Now, try not to guess. You'll have some multiple choice questions to do. What you want to do is go through a series of examples, especially using some of the numbers that I've given you here. So we can pick a couple of irrational numbers and try to add them together. So let's say you have pi plus pi again. Well, we're adding 2 irrational numbers, and pi plus pi is 2 pi. Well, that's still an irrational number, and you might think to yourself, well, if A and B are irrational and I add them together, I get an irrational number. But be careful. Go through some more examples in your head or write them down like I'm doing. If you have pi plus negative pi, and you add those together, you get 0, which is a rational number. Same thing with A times B. Pick a couple of irrational numbers. Maybe pick the square root of 2 times the square root of 3. Well, we know how to multiply square roots. That would be the square root of 6. That does not simplify. So in this example, you multiply 2 irrational numbers together, and we got an irrational number. However, you want to go through some examples and see if that's always the case. Well, what about the square root of 5 times the square root of 5? When you multiply those together, you get 5. So you see that when you are adding or multiplying irrational numbers, sometimes your answer will be irrational, sometimes your answer will be rational. So anyway, think through some examples like this, especially playing with the same number or similar numbers, to try to see some patterns. Anyway, I hope that helped. See you next time.